How are you and how was your day? Hope it was fine. Yeah. Yeah. You are all welcome. Tonight we'll be talking about or look at some trig identities. I'll just look at to recap what we have done. Then we proceed to consider, after solving one or two examples, we proceed to consider special angles. Is that clear? Mth122 trig and analytical geometry. Okay. Amen. Yeah. Yes. The other day we looked at some identities. Trig identities. Sorry. We looked at some identities. Amen. We looked at some identities the other day. So let me just remind us again. Yeah, you know, the other day we looked at our right angle triangle, right? This is theta. This is A, B, C, R, Y, X, right? This is hypotenuse, two of us. And this is opposite. Yeah. We looked at it that way the other day. Then we now recall SOTA. Then we said SOTA, so means tan theta, right? And this is equals to opposite over hypotenuse. This is equals to what? Y all over R. Car is equals to cos theta. True of us. Then this is equals to after z all over hypotenuse is x all over what? R. Then 2r means is equals to tan theta. This is equals to opposite all over what? This is equals to what? Y all over x. True of us, we did something like this, if I'm not mistaken. True of us. It's true, right? Okay. So, far so good. So as you can see now, we know very well that or we are able to prove how we got cos square theta plus sine square theta equals to 1, and with other identities. Is that clear? But tonight, we want to look at another example. Are you following? We want to look at another example. We look at one or two examples, then we move to special angles. Is that clear? Okay. So let's look at it again. Let's look at the question, prove that example, prove that tan x plus sec x, prove that tan x plus sec x all over sec open bracket, sec x open bracket 1 plus tan x sec x, tan x sec all over sec x is equals to 1. As simple as ABC. Yeah. So we want to prove that the left hand side is equals to the right hand side. Is that clear? I'm not saying computers engineering students. I don't know why. I'm not saying you guys. You are supposed to be part of this class, but I'm not saying you guys, computer engineering students, and the two. I'm not saying you guys. Okay, yeah. So let's look at it together. Let's look at it together. As simple as ABC. It is not difficult. So if you come across identities of this form, these are trig identities. You know, I told you that tan x is the same thing as what? Sin x all over cos x. True or false? Yeah. The other day, you have to remember all these things. Then, our sec x is equals to 1 all over cos x. True or false? And cosec x is equals to 1 all over sin x the other day. Amen? Then cot x is equals to 1 all over tan x. So, excuse me. So when you come across questions like this, you have to recall all these things. Is that clear? So now we want to prove whether the left answer will be equals to 1. So let's look at it together. Amen. So as you can see, note that tan x is equals to what? Sin x all over cos x. So let's write solution. Solution. It means this. Okay, let's write the question again. Plus sec x all over sec x open bracket 1 plus tan x all over sec x equals to 1, right? Okay, so what we need to do is, what are you going to do? If you can see what I am saying, note that tan x is what? Sin x. So sin x all over, instead of tan x, we write sin x all over cos x. Then plus, instead of sec x, we write what? 1 all over cos x. Then all over sin sec x open bracket 1 plus, you know that our tan x is what? Okay, tan x is what? Okay, tan x is, okay, sin x all over cos x. Then all over sec x is 1 all over cos x. True or false? It's true, right? Okay? But at this point, what you need to do, you look for the LCM. Any question before we proceed? Do you have any question? Any question before we proceed? Do you have any question? No question? No question, right? Okay. So we can proceed, right? So if you can see what I am saying, look here. If we have 1 plus sine x all over cos x, then all over 1 all over cos x. Let us consider the LCM here. So it means here we are going to have cos x plus sine x all over cos x, true or false? Then all over this, 1 all over cos x, true or false? So far so good. So here we are going to have, this is what we are going to have, then equals to 1. So this bracket we now have sine x all over cos x plus 1 all over cos x all over sec x, open bracket. This bracket is now this cos x plus sine x, amen. Then all over cos x all over 1 all over cos x. True or false? True or false? It's true, right? It's true, right? Yeah. So far, so good. So at this point, when we have, let's look at it this way. If we have A all over B, then all over 1 all over C. This is the same thing as A all over B, then divide 1 all over C. Then this is the same thing as A all over B. Convert this to what? Multiplication times C all over 1. Yeah, true or false? So we are going to do this way. Let's do it this way. So now this is cos x plus sine x all over cos x divide 1 all over cos x. True or false? So by the time we convert it, we are going to have cos x plus sine x all over cos x. Change this to multiplication. Are you feeling? Here will now be times. This denominator will come up, the numerator will come down. Cos x all over what? 1. Sorry. Okay? Do you agree with me? Any question? Do you agree with me? Any question? Any question? Do you agree with me? Any question? No question? So let's proceed. It means here okay. This is 1. It means here will now be sine, then this is equals to 1, yeah. Sine x all over cos x plus 1 all over cos x, right? Then all over sec x, open bracket, cos x plus sine x all over cos x times cos x all over 1. equals to what? 1. True or false? So, as you can see what I'm saying, this is sine x all over cos x plus 1 all over cos x. Okay, all over, sec x is the same thing as 1 all over cos x. True or false? Open brackets. Amen. Open bracket. You don't need the prophet to tell this and this will cancel. So we'll be left with cos x plus sine x all over what? 1. Then this is equals to 1. True or false? True or false? It's true, right? It's true, right? Okay? So far, so good. So at this point, what we need to do, use this to multiply. Yeah. Use this to multiply. Then, don't know whether we are going to arrive at answer. So here will now be okay. Oh. What is the question? 1 all over, okay. Okay. Yeah. If you can see what I am saying, take the LCM of this, the numerator. So the LCM will now be sine x plus cos x all over, look at it here, all over cos x, true or false, then all over cos x plus sine x all over, if you multiply out this bracket, is cos x, which is equals to 1. So you don't need the prophet to tell you. Look at it. It means this is the same thing as 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 sine x plus cos x all over cos x divide cos x plus sine x all over cos x equals to 1. Then if you convert this to multiplication, you're going to have sine x plus cos x all over cos x times, this one will come up, cos x all over cos x plus sine x equals to 1. Then I see that this cancels this and this cancels this. And I see that 1 is equals to 1. This is the final answer. Yeah. This is the final answer. This is the final answer. You mean it is not clear? It is not clear at all. Okay. So let's move to consider another example. Let's move to consider another example. Okay. Yeah. Let's consider another example. It says solve 5 cos square t. Example, solve 5 cos square t plus 3 sin t plus 3 sin t minus 3 equals to 0. I think, yeah. For values of t, for values of t, for values of t, for values of t from 0 degree to 360 degree. Is that clear? Let's look at this problem. Let's look at this problem. Okay, so far so good. Let's write solution. Our 5 cos square t plus 3 sin t minus 3 is equals to 0. True or false? True or false? It's true, right? So how can we solve this equation? Let's ask ourselves. You know, recall or note that cos square theta plus sine square theta is equals to what? 1. So now we are talking about t. So cos square t plus sine square t is equals to 1, right? Okay. So now this implies that our cos square t is equals to 1 minus sine square t. True or false? It's true, right? So now instead of, in place of cos square t, we write 1 minus sine square t. So look at it here. We have cos square t right here, right? So here we have 5 open bracket. Instead of cos square t, we write 1 minus sine square t, then close bracket plus 3 sin t minus 3 equals to what? 0. Amen? Okay? So let's multiply out this bracket. 5 times 1, 5. 5 times minus sine square t minus 5 sine square t plus 3 sine t minus 3 equals to what? 0. True or false? Any question at this point? Please drop your question in the comment section. Drop your question in the comment section. No question? So you mean we can proceed, right? Okay? So let us proceed. So as you can see now, this and this, we can subtract this and this. True or false? So if you can see what I'm saying, this is minus 5 sine square t plus 3 sine t plus 2, right, equals to 0, because 5 minus 3 is equals to 2. True or false? 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 So we have reduced this to a quadratic equation. If you can see what I am saying. Yeah, the class, if you can see what I am saying, we have reduced this to a quadratic equation. So now, what we need to do, use this minus to multiply to. So minus times minus plus 5 sine square t. Then here will be minus 3 sine t minus 2 equals to 0, right? This is a quadratic equation. True or false? So we have to find the factors of this equation, isn't it? You know how to solve a quadratic equation at this point. True or false? Can somebody help us out? Can somebody help us out? The factors of that equation. The factors of this equation is 5 sine t plus 2, then open brackets, sine t minus 1 equals to 0. So here will now be sine, this is a quadratic equation, sine t, 5 sine t plus 2 is equals to 0, then sine t minus 1 is equals to 0, right? So far so good. It means 5 sine t is equals to minus 2, then sine t is equals to plus 1. True or false? Okay, when we divide through by 5, we have sine t is equals to minus 2 all over what? 5. Then our t would now be equals to sine inverse of 1, right? Then our t here will now be equals to sine inverse of minus 2 all over 5. Any question here, please, before I proceed? If you have any question, drop it in the comment section before I proceed. You are not seeing. I think that should be from network. Okay, so far so good. So as you can see now, look at it here. Sine inverse of t is equals to minus 0.4000. Then consider this. But they said t from 0 degree to what? 360 degree. So you consider the arc sine of minus 0.400. Is that clear? You consider it, and this will give you 30 the degree. Is it 35? Just press your calculator. Yeah. Then you consider sine inverse of 1. What is sine inverse of 1? Press your calculator. Sine inverse of 1 you are not seeing clearly. Why? Can you see now? Okay, so far so good. So this is where we are going to stop for identities. So let's move to consider special angles. Special angles. You know very well that 0 degree to 270 degree is always required in sciences and engineering. True of us, it's true, which everyone know, because we make use of it every now and then, most especially your engineering drawing. True of us, it's true, it's required. So what we are going to consider is we are going to consider 30 degree and 30 degree and 60 degree. So let us have an equilateral triangle. Let's have it in this one. Okay. Amen. This is 60 degree. Here is 30 degree. Then here is x. Here is root 3 all over 2. We have A, B, D, A, B, C, D. Then x all over 2, x all over 2. Then here is x, here is x. This is an equilateral triangle. Is that clear? Okay. So now, what we need to do is our AD, that is the distance between A and D is equals to what? Square root of 3 all over 2x. True of us. Yeah, it's true, right? So now let us first look into consideration. So let's consider our sine 60 degree. Sine 60 degree is, note that your sine theta is always what? Opposite all over what? Hypotenuse. True of us. Which is equals to x all over r, right? Okay? Equals to x all over r, right? Okay, so if you can see what I am saying, sine 60 degree, this is sine 60 degree. So x all over what? R, right? True of us. Opposite all over. So right? Is opposite all over hypotenuse. True of us. Isn't it? Yeah, it is. So if you can see what I am saying. Oh, sorry, this is a y all over r. That is, if we have a right angle triangle of this form, this is y, this is arrow, this is x. Yeah, sorry. So take note. So now look at it. Opposite all over hypotenuse, true or false? And this is when you look at the equilateral triangle, you don't need the prophet to tell you. By the time you clean here, look at it, you clean here. Can you see your right angle triangle like this? True or false? Okay? So, yeah. So now, this will now be equal to sine 60 degree is opposite. This is our opposite. That is 3 all over 2x. Then, you said all over what? R, this is your x. This is x. True or false? Isn't it? Yeah, it is. So, you don't need the prophet to tell you. Our sine 60 degree is equals to what? Root 3 all over 2. True or false? True or false? Any question? True or false? I don't know, Awa, you said you don't understand. Huh? I don't know, Awa. You said you don't understand. Where? How? Then, let us also consider cos 60 degree. Cos is what? Cos theta is adjacent all over hypotenuse, right? This is equals to x all over 2 divide hypotenuse x, right? Okay, so cos 60 degree is equals to look at it. This is adjacent. This is x all over 2 all over hypotenuse is x, right? So x all over 2 divides x. True or false? So our cos 60 degree is equal to 1 all over 2. True or false? Any question? You have any question? Any question? Yes or no? No question? Okay. So we can proceed, right? Okay. So far, so good. Okay. So let us also consider tan 60 degree. Tan 60 degree is TOA. That is tan theta is equals to opposite all over adjacent. This is what? This is equals to here root 3 x all over 2 divides x all over 2. Amen? So if you can see what I am saying here, when we have root 3 all over 2x, then divide x all over 2. It means we convert this to what? Multiplication, right? The division sign. So 3 x all over 2 times, this one will come up, this one will come down, 2 all over x, this and this will cancel, this and this will cancel. It means is what? Root 3. So our tan 60 degree is going to give us root 3. So this is how we got our tan 60 degree cos 60 sin 60 degree. Now let's consider 30 degree. Let's consider 30 degree. Any question, please? Do you have any question? Okay. No question, right? You are not understanding because you are just coming. Mohammed, Ahmad. You are just coming. Okay. So now let's consider let's consider, we're able to look at 60 degree. Let's consider 30 degree. It means the angle will now turn. Yeah. This is how it is. This is how it is. 60 degree. This is 30 degree. We have 3 all over 2x. True of course, here is x. Then here is x all over 2. So if now we want to look up, here is 30. True of course. So it means the angle will now turn this way to be in this form. So now the angle will now be in this form. Okay. Let's turn the angle. The angle will now be in this form. If we turn it, it will now be in this form. Yeah. So this is our 60 degree, and this is our what? 30 degree. True of course. This is our x all over 2, then root 3 all over 2x. Yeah. It will now turn this way. Can you see now? Because if you turn this angle, this is how it will look like. Is that clear? Then this is our x. Is that clear? Okay, so let's look at it together. So our sum 30 degree is equals to the same approach, which is what? So opposite all over what? Hypotenuse, right? So here will now be root 3 all over 2x all over x. Then our sin 30 degree is equals to this and this will cancel. True or false? Will give us root 3 all over 2. True or false? True or false? Oh, sorry. Okay. Yeah. Sorry. This will now be x all over 2. Then this will now be 3 root 3 x all over 2. Sorry, I'm sorry about the mistake. Because when once this angle turn, this adjacent will now become the opposite. Then this opposite will now become the adjacent. Sorry about the mistake. Is that clear? I'm very sorry. Sorry about the mistake. Okay? Very sorry. So it means we go by SOHCAHTOA. Okay? So this sin theta is equals to opposite all over hypotenuse, which is equals to our opposite is this x all over 2 then divide x, right? So this and this will cancel. Oh, we are talking of the theta. Our theta is 30 degree. 30 degree. So this sin 30 degree will now be 1 all over 2. Now, so sin 30 degree will give us 1 all over 2. Cos 30 degree is equals to the same thing applicable here. Cos theta is equals to what? Adjacent all over hypotenuse. Then our adjacent is root 3 all over 2x divide what? Hypotenuse x. So this and this we cancel. True or false? If this and this cancel, we are going to have root 3 all over 2. Then tan 30 degree is equals to tan theta is equals to what? Opposite over adjacent. Then our opposite is x all over 2. Then all over adjacent is root 3x all over 2. So if you can see what I am saying, don't need a prophet. So assuming you have x all over 2, then divide root 3x all over 2. It means by the time you convert this to multiplication, you are going to have x all over 2 times 2 all over root 3x. So this and this will cancel, this cancel. 2 of us. Then we are going to have 1 all over root 3. But we are not going to stop here because of the denominator is in short form. So you have to rationalize. Is that clear? So this is equals to 1 all over root 3 times root 3 all over root 3. Then this will now give us what? 1 times root 3 is root 3 all over root 3 times root 3 is 3. So therefore, this is root 3 all over 3. This is how we are going to consider special angles. So, do you have any question that you want to ask? Any question? All these things I'm doing here, you might see them in your exam. So please don't play with them. Don't play with what we are doing here. So let's proceed to consider a 45 degree. Yeah, let us proceed to consider 45 degree. 45 degree, right? Let's proceed to consider 45 degree. Okay. Let's have a rectangle triangle. Here is root 2x, right? X. Here is x over 45 degree. Let's name A, B, and C, right? Okay. So now, 45 degree. What is sine 45 degree? Sine theta is opposite all over what? Hypotenuse. So here is x all over root 2x. Then this and this will cancel to give us 1 all over root 2. True or false? But because of sod here, we have to what? Rationalize. So our sine 45 degree now equals 1 all over root 2 times root 2 all over root 2. Then this is going to give us root 2 all over root 2 times root 2 is 2. True or false? Any question? Yeah. Then cos 45 degree is equals to adjacent all over hypotenuse x all over root 2x. This and this will go. Give us 1 all over root 2. True or false? So it means we are going to do the same thing. So our cos 45 degree, when you look at this, if you rationalize, you arrive at the same answer. True or false? This is equals to root 2 all over 2. This implies that cos 45 degree and sin 45 degree, they are all the same. Then let's consider tan 45 degree. This is equals to opposite adjacent. It means it's 1. True or false? Because this is x all over x. This is equals to 1. So this implies that tan 45 degree is equals to 1. Any question before we proceed to solve some examples? Do you have any question that you want to ask? Any question? Please, if you have any question, ask. Do you have any question? Any question? Yes or no? Because we want to solve some examples. No question, so we can proceed, right? Okay, let's proceed to solve some examples. Find the exact value of tan 30 degree. Example, find the exact value of tan 30 degree plus tan 45 degree. Tan 45 degree. Then all over 1 minus tan 30 degree times tan 45 degrees, right? Okay. It's simple as ABC. Yeah. It's simple as what? ABC. So let's look at this. Not too long, we just our tan 30 degree plus tan 45 degree all over 1 minus tan 30 degree times tan 45 degree. You know very well that tan 30 degree is what? Is root 3 all over 3. True or false? It's true. Then plus, what is tan 45 degree? Is 1, isn't it? 1 all over 1 minus tan 30 degree is root 3 all over 3 times tan 45 degree is what? 1, right? So this is equals to root 3 all over 3 plus 1 all over 1 minus root 3 all over 3 times 1 is the same thing as root 3 all over 3. True or false? Any question here? You will see this question in the exam. It's very important. Take notes. Take note. You will see it in the exam. These questions. Okay? So far, so good. So far, so good. So this is equals to, let's take the LCM, root 3 all over 3. The LCM of this. Let's take the LCM. If we have root 3 all over 3 plus 1, LCM is what? 3, right? 3 to 3, 1 times root 3. Root 3. 3 to 1, 3, right? Times 1 plus 3. True or false? Then the same thing applicable here. So the numerator will now be root 3 plus 3 all over 3 all over the same thing applicable here. 3 minus root 3 all over 3. Then this is the same thing as root 3 plus 3 all over 3 divides 3 minus root 3 all over 3. Amen? Okay? So far, so good. We convert this to multiplication. This is equals to root 3 plus 3 all over 3. This one times the denominator will now come up. Sorry about that. NEPA has taken power. So we have to suspend the class. We have to suspend it. Thank you very much. NEPA has taken power. Let's suspend the class.